Go on, my GCSE people, welcome back to another video. Now in today's video we're going to be looking at electrolysis. Now a lot of you think that electrolysis is a difficult topic, but I can assure you it's a very straightforward topic. Now one of the things that you must understand about electrolysis is firstly its definition. So it's all in the word electricity and lysis. The word lysis means to split. So electrolysis is the splitting of compounds using electricity. Okay, now you need to ensure that you have an understanding of the setup. So here we have the two electrodes, one on the left, one on the right, and that is what conducts the electricity. Okay, that's what takes the electricity to the solution. One is going to be negative and one is going to be positive. Okay, then you have the electrolyte. The electrolyte is the liquid solution that is being broken down by the electricity, and in this case our electrolyte is copper sulfate, that blue solution. Now in electrolysis you must have a power pack, okay, or some sort of battery or source of electricity. Okay, so if you notice here, the negative end is called the cathode and the positive end is called the anode. And in your electrolyte, which is normally an ionic substance, you have an anion, which is negative, that is going to be attracted to the positive end, and the cation, which is positive, that is going to be attracted to the negative end. So your cations go to your cathode and your anions go to your anode. Okay, ensure that you know how to do a simple drawing, as it may be asked in the exam sometimes. Now I don't want you to panic because you're hearing all of these terms. You can use this to remember that your positive electrode, okay, so your positive electrode is your anode, so positive anode, and your negative electrode is your cathode. Okay, and you should remember that your cations, which are positive, they're going to be attracted to your cathode because your cathode is negative, as opposites attract. Okay, so once you know all of that and know your drawing, your next thing that you need to understand is that your electrolyte is normally an ionic compound. Now what I have here is an ionic lattice structure, okay, that could be made from your positive and your negative charges. Okay, now it's very important that you understand that in your ionic lattice structure you don't talk about delocalized electrons. You must be using the word ions. Now when it's a solid, these ions are in a fixed position, and therefore the ionic compound cannot conduct electricity because the ions are not free to move. This is a commonly asked question. Okay, now what do you need to do to the structure? You need to melt the structure, or you need to put that in a solution, dissolve it in a solution, and when that happens the ions are now able to move and can carry a charge. A very commonly asked question. So they would say to you, why is it that it needs to be molten? Because the solid, the ions cannot carry a charge, they cannot move, current cannot flow. Current is the movement of electrons. Now, here's an example. We're now using molten lead bromide for electrolysis, okay? Now, lead bromide is made from Pb2+, okay, and Br-, okay? So lead bromide has a formula of PbBr2. So those are the two ions found in lead bromide. Now why should we melt it? We just spoke about that, all right, so that the ions are free to move. Now what will happen is that your lead ions, which are positive, is going to go to the cathode, okay, and your bromide ions, which are negative, that's going to go to your anode, all right, when you switch your circuit on. So what you would see, or what you'd observe, is bubbles being formed here, bubbles being formed there, and lead being deposited down at the bottom. Okay, Now, when the lead gets to the cathode, it doesn't remain as an ion, and this is where lots of students have issues. The lead is now converted into lead atoms or lead metal. Now, how does it do that? It needs to gain 2 electrons. Okay, and that's what you now call a half ionic equation. Now you might ask, where is it gaining that electron from? It's going to gain an electron from bromide at the anode, which goes to form Br2. Okay, bromide, or bromine rather, doesn't like being by itself. It comes in pairs. Okay, now straight away you look at this, you realize that that's not a balanced equation, so we need to balance the equation. So we're going to put a 2 here, all right, and it will need to lose 2 electrons. Now electrons which are lost, we put that on the product side. Now the same 2 electrons which are lost here are the same 2 electrons which are going to be gained there. So at the cathode, because you're gaining electrons, that is called reduction. So reduction always takes place at the cathode. Always. Okay, reduction at the cathode. And oxidation always takes place at the anode. Okay, so there's a term that you could use for that, and that is oil rig. Okay, oxidation is loss of electron, reduction is gain of electron. Okay, good. Now back to the bromide here. There are some elements that you need to know that they come in pair, and we can use this term to remember the elements which comes in pair. Hofbrinkel. So these elements don't go around by themselves. H2, O2, F2, Br2, I2, N2, Cl2. Alright, these elements go around in pairs. Okay? Good. Let's move on. So, we just spoke about oil rig. Let's look at another example. Let's look at sodium chloride. Alright? Table salt as a molten electrolysis of sodium chloride. So, your sodium is going to go to your cathode, which is negative. Remember, do not panic. Positive anode, negative is cathode. So that's my anode here. So we switch the circuit on, opposites attract. Now my Cl is right there. So my Cl will lose electrons. Okay, so you end up with this process taking place. Cl minus going to form Cl2 plus 2E minus, all right, because it's going to lose 2 electrons. We need to balance, so that's 2E, 2Cl rather, okay. Those electrons are going to travel around the circuit here to be accepted by the sodium. Metals are always loners, okay. So your sodium, which is Na+, they're going to gain an electron to form Na. Alright, good. And if you want to be ultra correct, alright, or if you're A levels, you would have 2 Na accepting the 2 electrons to form 2 sodium atoms. And that process that takes place there is reduction. Okay, so just remember the term oil rig. Oxidation is loss, reduction is gain. Now, not all the times you will have molten electrolytes. There are sometimes that your electrolyte will contain water, and this is what tends to get to student head. Okay, now you need to know that water could also be split, as water is a covalent compound, but when you pass electricity through it, it can split to give you your H+ ions and your OH- ions, okay, which is shown there. So if I now have a solution aqueous solution, I will no longer have 2 ions, as mentioned previously. I will now have 4 ions. My sodium ions, okay, my hydroxide ions from my water, my chloride ions from my sodium chloride, okay, my hydrogen from my water. So now you have 4 ions. Now, how does this affect the products being formed? Now, what you will end up having when I switch my circuit on, 2 sets of ions migrate to the anode and 2 sets migrate to the cathode. So remember, negative is cathode. We will not panic. So my negative end is my cathode, my positive end is my anode. We will never panic. Okay? Now, we have to now make a choice. Now, how am I going to choose which one is going to come off at the anode and which one is going to be produced at the cathode? Now, at the cathode, right, we are going to choose the one which is less reactive. So at the cathode, we're going to choose the one which is less reactive. So instead of sodium being produced, it's going to be hydrogen. All right, so think about your half equation. Your H plus ions will go to form H2. Remember Hofbrinkel. They don't like being by themselves. Is it balanced? No. So we need to put 2 here. Okay, so we have 2 hydrogen there. It's going to form H2 gas. Okay, now will it lose or will it gain? Remember, at the cathode, right, reduction always takes place at the cathode, and reduction is the gain of electrons. So we're going to gain 2 electrons. So just remember all the rules. Okay, you can pause the video and write your rules down. All right, so that is the equation there. Now at the anode, sorry, at the cathode rather, don't panic. So positive anode, negative cathode. So positive anode, negative cathode. So we've just dealt with the cathode. All right, so we need to now make a choice. Am I going to choose the chloride or am I going to choose the hydroxide? Now, if you have a halogen or a halogen, however you pronounce it, right, we will always choose the halogen or halogen, okay? So once the halogen is present, we are going to choose the halogen. So, bye-bye OH, Cl is the one that's going to be produced. So it's going to form Cl2. Remember, Hofbrinkel. All right, straight away you realize that it is not balanced. So we need to put a 2 there. Okay, and it's at the anode, so oxidation always takes place at the anode. Oxidation is the loss of electron, oil ring, so I'm going to lose 2 electrons here. Okay, so what you will actually see is bubbles of chlorine gas being given off, and of course you can test that gas by using damp blue litmus paper. Look at my previous video. Okay, so let's see, which one are we going to choose here? Now that we don't have a halogen, if you don't have a halogen, then we're going to choose hydroxide. All right, and hydroxide will always form water and oxygen gas, and this is the equation that you need to know. Okay, so just make sure that you remember this equation if you're forming hydroxide. So what you will see is bubbles being produced, and that bubbles would be oxygen gas. All right, so here are the rules. Just to summarize everything that we've said so far. If you have a halogen present, the halogen will be produced. Oops. The halogen will be produced. If it's not a halogen, then it will be oxygen and H2O will be produced from the hydroxide. Okay, remember we said that you need to know that equation, which is OH minus going to form H2O plus O2 plus 4E minus. Okay, not balanced, so we need to put a 4 there, and we need to put a 2 there. All right, make sure you know that equation. If your positive metals are so if your positive metals are like potassium, sodium, calcium, and all of these reactive metals, then it's going to be hydrogen which is produced once water is present, okay? But if it's less reactive than hydrogen, then the metal will be produced. So this is the rule that you need to know for solutions, okay? Please remember to like, share, subscribe, go over to my YouTube channel, or go over to my TikTok account, GCSE Science Boss. Anyone will do. Alright, all the best in your GCSE.